Greetings to all of you. In today's session, the topic is about intermediate chemistry, which will be fetching for your international entrance or any competitive exam you are preparing for. India level JE Advanced and JE Mains examination for engineering stream, IIT and NIT entrance examination, NEET chemistry for medical entrance across the India, Telangana and Andhra Pradesh MCET examination for engineering stream. Again, it is the technical domain. In addition to all these, you are seriously preparing for any government organized examination. In that case, general studies paper will be the common to all the aspirants. So in that general studies paper, our content will be there coming from general science. In that, the topic what we are discussing is very much fetching. Let's enter into our today's session. Explain the geometrical isomerism of following compound as per the IUPAC protocol. Geometrical isomerism is applicable to the compound where double bond is resided among two carbon atoms. So based on the arrangement around the double bond, we can assign geometrical isomerism. Geometrical isomerism can be taken whenever double bond is present. Here, EZ nomenclature. Geometrical isomerism can be mentioned in cis trans and EZ as well. E for entagagin, Z for jusamin, right? So entagagin means what? If the higher priority both are in opposite direction, higher priority around the carbon-carbon double bond are in the opposite inclination, we can say E stereoisomer. And if two higher priority groups are in the same side of the double bond, that is said to be Z. Z is nothing but same side, which is called a cis1. And if both are opposite with respect to each other, that is called E, which is called a trans isomer. Fine. E for trans, Z for cis. This is the way EZ nomenclature will be assigned. If we apply the same for our compound, this is the methyl, this is the fluoro. Being carbon is made up of 6 atomic number, fluorine atomic number is 9. Always, according to Canning-Gold-Prelog rules, higher atomic number, higher priority. So fluoro with 9 atomic number will given with the what priority number 1 and carbon priority number 2. But in the second carbon atom, if you observe the second carbon atom of the double bond, you can find two carbons only, two substituents carbons only. Then there is the ambiguity in order to assign the name for or priority for the compound. Here you can find 1, 2, 3, 3 carbon length chain, and here 2 carbon length chain. 3 carbon length chain obviously of higher priority over 2 carbon length chain. That's the reason why 1, 1 are inclined in the opposite direction. If both are opposite direction, so that we can say trans. Trans is called what? Trans is called entagagin. E isomer it will be. So whatever compound provided is the E isomer. This is according to geometrical isomerism as provided by IUPAC nomenclature. This is the way. For question number 1, the compound is E isomer, trans isomer. Both the higher priority groups are in the opposite direction, right? So after getting that E, let me go with IUPAC name of the compound. In order to name the compound as per the IUPAC, wherever fluoro is there, that direction you have to start numbering. Fluoro is there and the second carbon, if this is the carbon number 1, 2 fluoro we can write. And on third, we have ethyl, right? So third carbon ethyl, second carbon fluoro. EF. So as per the IUPAC protocol, alphabetical order, E comes first over F. That's why 3 ethyl, 2 fluoro. And how much length we can go for? Longest chain is the parent chain, right? So that 1, 2, 3, 4, 5, 6 carbon chain, so that hexane. And on that hexane, again, second carbon is having a double bond. So that the entire name will be 3-ethyl, 2-fluoro, 2-hexene. This is the way we can write 2-hexene. Being it is alkene, we can write a hexene. So for compound number 1, 3-ethyl, 2-fluoro, 2-hexene is the IUPAC nomenclature. And moreover, geometrical isomerism will be E. E for trans, entagagin it will be, right? So move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. A gas is released at the point P and the apparatus shown. And here the damp universal indicator paper was kept over here, where the vapors of this gas are passing through this indicator paper. Which gas turns the damp universal indicator paper red most quickly? Indicator paper will turn into red color whenever the gas is that gas to be identified. Fine. Ammonia, chlorine, hydrogen chloride, sulfur dioxide. Among these many, here the condition required in order to measure the color change. They mentioned red color is the final transformation. So in order to identify, first of all, we have to know what is meant by universal indicator, what color change you can notice, and what ingredients in order to prepare universal indicator. A universal indicator is a pH indicator used to measure the nature of the compound in terms of acidic, neutral, and alkalinity, right? So it is the pH indicator composed of blend of several compounds in it. Exhibits several smooth color changes in the pH range changes from 1 to 14 to indicate acidity, basicity of the solutions. Definition. A universal indicator are typically composed of water, propane 1-ol, naphthalene indicator, naphthalene with sodium salt, sodium hydroxide, methyl red, bromo, thymol blue, monosodium salt, thymol blue, monosodium salt. These many components are required in order to prepare universal indicator. Whenever universal indicator was prepared, if the compound is acidic, the immediate color change to red, orange, pale orange, yellow. So up to this yellow in color, all are said to be what? Acids. If a universal indicator turn to neutral so that you can acquire green color, universal indicator is turning into blue color like a sky blue, navy blue, violet blue, dark blue, this is royal blue, purple blue, pinkish blue. So these many blue colorations you can notice. All these are regarded as alkalinity. They are indication for the alkalinity, nothing but basicity. Fine. As the blue color intensified, alkalinity also increased. This is a way. Universal indicator is the measure of nature of the compound, either acidic, neutral, or alkaline in nature. They mentioned for if the compound, if the gas that used to turn it into a red color, if it is red in color, that indicates the compound is intensely acidic, strongly acidic. Fine. So that is given by, I'm taking universal indicator paper without any coloration, and these bubbles are allowed to pass through this universal indicator. These bubbles are made up of hydrochloric acid. Being hydrochloric acid is very strong in nature, let me allow these bubbles to surround this pH indicator, universal indicator. Whenever these bubbles are surrounding, now this universal indicator turned into intense red color. You can clearly see how to indicate intense red color over here. Intense red color indicates the acid is very strong in nature, right? So among all the options, obviously ammonia is basic, weakly basic, chlorine neutral in nature, hydrochloric acid is the strong acid, SO2 is acidic in nature, but compared to mineral acid, SO2 is the weak acid, and whenever it hydrolyzed, whenever sulfuric acid or sulfuric acid formed by the addition of water, so that its intensity of acidic nature greatly enhanced. But as of now, sulfur dioxide is acidic, no doubt, but the thing is weakly acidic in comparison with the mineral acid, hydrochloric acid. Fine. The correct answer for the question number 2 will be C. That will be indicated with the red color, hydrochloric acid. Move on to question number 3. Question number 3 is collected from JEE Advanced 2019 question paper, paper 1 question it is. It is a comparative study of acidity of various carboxylic acids. The correct order of acid strength of the following carboxylic acid is Acid strength to be depicted. In order to identify acidic strength, here the triple bond in conjugation with the carboxylic acid, double bond is in conjugation with carboxylic acid, benzene ring is in conjugation with carboxylic acid, and here carboxylic acid no way conjugation, rather this is the ethyl. Propionic acid, propanoic acid it will be. Among all, it is very clear that whenever electron releasing are there, acidic strength decline. Whenever electron withdrawing is there, acidic strength inclined, right? So here, this is the way you can clearly measure. Greater the electron pulling nature, greater the strength of acid. Greater the electron releasing nature, lesser the strength of acid. This is the way we can correlate acidic strength and electronegativity of the given compound. Obviously, triple bond is more electronegative compared to double bond, and remaining also that the compound one is having high electronegativity and high acidic strength is accorded. That's the reason why compound one is of higher acidic. Whenever acid is nothing but any compound used to liberate H plus. Whenever H plus liberated, the formed carboxylate, that is called what? Conjugate base. The conjugate base must be stabilized in the efficient way. That can be stabilized in the maximum extent due to conjugation with the triple bond over here. That's the reason why it is of more acidic strength. And the next level will be second, and the third will be of third level, and this is the least one being electron releasing will decline the acidic strength. Fine. So that compound 4 is of extremely lesser the strength of acid. Let's see in detail. pKa is the measure of acidic strength. There is a reciprocal relation. Higher the pKa, lesser the acidic strength. Lesser the pKa, higher the acidic strength. Reciprocal relation will be accorded. So whenever this what we can say triple bonded carboxylic acid was taken, whose pKa is given by 1.89, and this double bonded carboxylic acid when taken, 4.3 the value will be, and a benzene ring in conjugation with carboxylic acid 4.5 it might be. CH3 CH2 COH, propanoic acid when taken 4.87. What we mentioned, lesser the pKa value, higher the strength of acid, so that wherever triple bond is there, there the acidic strength of carboxylic acid is extremely larger, being pKa values lesser. And higher pKa accorded for the electron releasing ethyl, so that we can say this is of this is a less strength carboxylic acid. Let's see what the kind of mechanism behind this kind of acidic strength and triple bond, double bond, benzene ring, and this electron releasing. We can clearly explain by means of its hybridization. Whenever single bond is there, represented with sp3, double bond sp2 hybridization, triple bond sp hybridization will be provided. If you observe sp3, one s-arbitol mixed up with the 3 p-arbitols, so that the combination will be 1:3. So we can say contribution of s-arbitol is 25%, p-arbitol contribution 75%. 3 orbitals are there, no? So that 75%. 25% s character in case of sp3. sp2 hybridization, 1 s-orbital and 2 p-orbitals. 2 p-orbitals are having 66%. Next, 1 s orbital is having 33%. Overall, it must be rounded up to 100, no? So that 3 orbitals equally contributed. How can we say? So 1 s orbital 33.3, 1 p orbital 33.3, 1 p orbital 33.3. Total, it will become 100. So this is the way s orbital contribution will be 33.3% s character. If you see sp means what? How extent s is there, that extent p is also there. sp only 1 s orbital, 1 p orbital, so that we can say 50-50. 50% s character is contributed in case of triple bonded compound. If you observe, single bonded is having only 25% s character, double bond 33.3, triple bond 50% s character. More the s character, more the percentage of s character, higher will be the electronegativity. Obviously, acetylene is more electronegative carbon. Double bond is somewhat less electronegative carbon, and the least electronegative carbon is of alkane, means a single bonded, because of 25% is character. This is the way electronegativity order will be sp highest, sp2 next level, sp3 will be least. So this is about what is character and electronegativity relationship. After getting that relation, electronegativity quantifiable values are mentioned over there. So hydrocarbon is alkane, alkene, alkyne. Hybridization will be sp3, sp2, sp. S character, percentage of S character will be 25, 33, 50. Electronegativity of sp3 carbon will be 2.48, and sp2 carbon will be 2.75. sp carbon will be 3.29. This is the way we can go for what correlation between the S character and electronegativity values. As S character increases, electronegativity also quantifiable value increased. Moreover, acidity of carboxylic acid depends upon the substance attached on the carboxyl group. Okay, negative charge can effectively delocalize electron withdrawing group when present. Resonance and inductive effect will be operated so that electron withdrawing group of carboxylic acid conjugate base will be highly stabilized. As a result, more acidic strength will be imparted. Electron withdrawing more favorable for more acidic nature. However, electron donating groups destabilize the conjugate bases so that they will reduce the acidic strength. It's a clear indication. More electronegative is there for this carbon atom, so that high strength of carboxylic acid, that is given by 1.89 pKa value. And next level, sp2 carbon is having next level of what percentage of its character and electronegativity, so that its value is the 4.3 pKa, and next level acidic strength. If you go with the benzene ring, so that electron releasing is there, this is a inductive effect, plus I effect will be operated, and so that we can say it is somewhat less strength, so that 4.5 will be the pKa. And in case of this one, plus I effect fully operated, no electron withdrawing, rather electron releasing is there. Electron releasing will destabilize the conjugate base of this one, so that it's unfavorable for the acid, and its pKa value extremely large, so that acidic strength is extremely small. That is the right order. One will be higher, next level 2, next level 3, next level 4. So whatever compounds are there in the same level, decreasing order of acidic strength will be assigned. This is the way. Question number 3 is deeply understood if we are clearly understand S character relation with electronegativity, hybridization in the given organic compound, in what way electronegativity plays a vital role in the acidic strength, and how can we stabilize further. So many concepts included in order to explain this, so that it is a most logical question. Move on to question number 4. Question number 4 is collected from JEE Advanced 2019 question paper, paper 1. Calamine, malachite, magnetite, cryolite respectively. All these are, if you read all the things twice, you can clearly get the idea about them. This is a topic collected from metallurgical process. Metallurgy is the process where complicated minerals and ores were collected in the bulk or quantity. After the series of refinements, the entire molecules and any unwanted side products are present, they get totally discarded. And the pure metal or pure compound, what you are aiming for, that can be collected in a minute but a maximum extent of purity. That is the way metallurgical process will be proceeded, where you are going to treat with the multiple number of components like solvents in order to discard the solvent dissolvable impurities. Later you can go with the chemical treatment method like reduction, oxidation, a kind of different reactions will be performed in order to make the compound more pure, more clear. And electrolytic conditions also applied, oxidation, reduction, release of electrons, acceptance. These many methods are applied in order to make the compound more pure. right? So all these are the series of steps involved in the metallurgical process. They're asking for the ores are provided, their chemical composition is required to be mapped. In order to give that one, correct answer will be calamine is mentioned with the zinc carbonate, malachite is mentioned with copper carbonate, copper hydroxide, magnetite is given with Fe3O4, ferric oxide we can say, cryolite is sodium aluminum hexafluoride. These many what ores are there and their respective composition is also mentioned. Let's see in detail. This is the process called metallurgical process, where high thermal conditions are required to be operated, and the device called furnace, kiln, that kind of a huge device where you can go with the elevated temperature in order to melt the ores, melt the minerals, and make the compound in highly purest form. So that's the reason why this is the device which is purely operated at pyrolytic conditions. Extremely high temperature is required to be maintained. And the device is also made up of refractory linings, refractory coatings where thermal resistance can be accorded in order to avoid the deformations, right? So this is the entire representation for metallurgical operations. And this is the ore called what, calamine, which is composed by zinc carbonate. It is the ore of zinc. If you are going to make the series of reactions, a pure zinc can be collected, zinc metal will be collected. And this is called malachite green existing in green in color. And go for the series of reactions, purest copper will be collected because malachite green is copper carbonate, copper hydroxide, together they existed. And another is about magnetite. Magnetite is having the composition of ferric oxide, oxide form of iron. It is available in the bulk quantity and can be extracted and subjected to various reactions. This is called what? Cryolite. Cryolite is made up of Na3Al(F6). Na3Al(F6) is pronounced as sodium hexafluoroaluminate. This is the name of cryolite. It is most important in the metallurgical process. By that, we completed the entire mapping of all the compounds. For question number 4, option number 4 will be the correct answer. Calamine is zinc carbonate. Malachite is copper carbonate, copper hydroxide. Magnetite is ferric oxide. Cryolite is Na3Al(F6), sodium aluminohexafluoride. So this is a question from metallurgical process. Fourth option is the correct answer. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Common Entrance Examination, where organic chemistry part is given, and moreover it is selective for the reagent chemistry. You are taking naphthalene and having beta position double bond OET. This is called what? Ester, right? So ester compound is there in the beta position. Suitable reagent to be identified, to be anticipated, and finally ester converted into aldehyde. Else chemical composition is not altered. Whatever naphthalene is there, same naphthalene is located. Only this functional group ester now converted into aldehyde. What is the suitable reagent for ester to aldehyde transformation? That is Dibal H. Dibal H is the selective reagent for ester to aldehyde. Dibal stands for di, di, isobutyl. So B for isobutyl, A for aluminium, Al for aluminium, sorry, H for hydride. Let me repeat once again. D for di, I for iso, B for butyl, Al for aluminium, hydride for H. This is the way diisobutyl aluminium hydride is designated as Dibal H. Dibal H is called the reducing agent. How can we say reducing agent? We are removing OR removal and addition of hydrogen. Addition of hydrogen is called reduction. Removal of oxygen is called reduction. So that Dibal H is called a reducing agent by releasing hydride. H for hydride here. Hydride means what? Hydrogen accomplished with a negative charge over there called hydride. That hydride will be attached over there. Simply we can say substitution. OR replaced with H minus. And it's a formula, Dibal formula is provided. Diisobutyl aluminum. Isobutyl means four carbon chain, one side, four carbon chain, another side. And aluminum is also having one more bond with the hydrogen as the hydride, H minus, because aluminum electropositive electrons, bonded electrons will be carried away with the hydrogen, so that hydride will be there. Diisobutyl aluminum hydride is a dibal, which is a strong reducing agent specific for ester to aldehyde transformation, which is accorded in option number 3. For question number 5, option number 3 will be the correct answer. Move on to question number, let me give a detailed mechanism over there. Whenever diisobutyl aluminum hydride dibal, it is in contact with ester. Ester electrons, oxygen electrons will be bonded to aluminum. Whenever bonding is there, positive charge is acquired and hydrogen will be shifted to the carbon, and we will get a kind of ether linkage over there. Later on water will be added. Whenever water is added, what it will do, the bond will be shifted this side and this simultaneous methoxy will be removed. That methoxy, whatever removed, will be attached at aluminum initially hydrogen is there, OCH3 here, OCH3 is grabbed, and here we will get C double bond O, because the bond is cleaved, no? So that aluminum oxygen bond got cleaved and the electrons polarized towards the double bond like this, and this methoxy will be removed, finally turned into what bond? Aldehyde bond. This is the detailed mechanism for the Dibal reduction. And last question of the session, question number 6. The product formed in the following reaction. We are taking Narbonane derivative, and here oxime is there. Double bond NOH is called what? Oxime. Oxime is the product of ketone with the hydroxylamine. When this oxime is treated with sulfuric acid, we are expecting a ring cleavage, ring opening reaction, so that we will get these many atoms are there. How many? 1, 2, 3, 4, 5, 6, 7 atoms are there in the Narbonane cyclic ring. Now, after the ring opening, the ring size concise to 5 membered only. Wherever 6 membered is there, you can clear you can exclude this option. 5 membered ring will be generated. In order to explain how can we achieve this product, we have to go for detailed mechanism. This is the oxime derivative of Narbonane, where sulfuric acid and water is added. Simply I am mentioning H plus. H plus will be attached to OH, so that oxonium ion will be generated. Highly unstable, can accept the electrons, so that moved away as a water. Whenever water removed, simultaneous bond mobilization, we can notice this carbon-carbon bond broken, and here it used to give the electrons in between carbon and nitrogen as a triple bond, and simultaneously, in order to make the balance, one of the H plus removed from the bridge head, and these bonded electrons are shifting over there, so it will be turned into a double bond like this. One side we have C triple bond in either side we have carbon-carbon double bond over there. If you clearly observe this, whenever this ring got opened, 7-membered ring now concise to only 5-membered. Let me count. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Only ring is of 5 carbons. So let me put 5 carbon ring. And at this carbon, we have 1 methyl, 1 CN. 1 methyl, 1 CN are there on one of the carbon. Another carbon is having double bond. Another carbon having double bond. And that double bond linked with 2 methyl over there. Double bond linked with 2 methyl. This exact configuration is provided with the 5-membered cyclic ring. That is purely mentioned, purely mapped with the option number 1. For question number 6, option number 1 is the correct answer. It is the kind of question where you can notice the rearrangement. Ring cleavage reactionity will be under acidified conditions. This is the way we completed the entire session where all the topics got discussed in a detailed manner with authentic references, authentic information collected from the authorized domains of internet, and whatever questions we discussed which are previously examined in various regions, so that all authorized question papers got collected, and informative session will be conducted over there with the multiple dimensions of the chemistry. In this context, whatever we are acquiring the knowledge over here will be very much fetching towards your entrance and competitive exams as well. Definitely, the people who are following this kind of content will be reaching their goals in the field of chemistry. I hope the session is really informative, and I'm sincerely requesting all the people to like the channel, comment which part is really important and interesting for you, and share with us parents who are serious about the preparation towards chemistry and more enthusiastic for chemistry content in terms of entrance or else any competitive exam. Subscribe the channel to receive more updates in the near future. Thank you one and all for your patient listening. We will go with a new content, and multiple chemistry questions will be covered in the near future. Thank you.